Good morning. Today I'd like to continue talking about trig substitutions. Previously, we looked at substitutions that involved radical a squared minus u squared. Today we'll look at those involving radical a squared plus u squared. The substitution that we'll use is u equal a times tangent theta, where the theta is strictly between negative pi over 2 and pi over 2. If you make that substitution on the indicated range, the square root quantity works out to be a multiplied by secant of theta. As before, we'll look at a few examples of this kind of thing. I'd like to look at the integral of square root of 1 plus 4x squared with respect to x. 4x squared is what I get when I square the quantity 2x. So this is of the type that we're talking about. The a will be 1, and the u will be 2 times x. It is u that's equal to a times tangent theta. Making what are now hopefully routine substitutions, I find out that I have to integrate 1/2 integral secant cubed theta d theta. If you look at the list of recipes, the suggestion is integration by parts. Since I know I'm going to have to do some integrating by parts, I'm going to create a letter to indicate the answer that I want. 1/2 integral secant cubed theta is what I'll call r, which is, in other language, 2 times r is the integral secant cubed theta d theta. Here I'll do integration by parts. The dv will be secant squared theta d theta, and the u will be secant theta. If I carry out the integration by parts, after simplifying, the thing that I'm trying to calculate, the r, is equal to tangent theta secant theta minus secant cubed theta d theta, which is 2 times r, inside the brackets, minus integral secant theta d theta. Dropping the brackets, r is tangent theta secant theta minus 2r, and then minus or plus the integral of secant theta d theta, which is on the list of things that we know how to integrate. Add 2r to both sides to move all the r's over to the left. An antiderivative of secant theta d theta is natural log absolute secant plus tangent. Add the constant of integration on. If I was willing to accept my answer in terms of theta, I would be done. If I want my answer in terms of the original variable x, I have to deal with these secant and tangent functions. The literal substitution that we did was 2x equal tangent theta, or to be a little bit more suggestive about it, tangent of theta is 2 times x. If I draw my triangle, tangent of theta is the length opposite divided by the length adjacent, and 2x over 1 will work. The other side in the triangle is the square root of the sum of the squares of the other two sides. Now that I know all three sides of the triangle, it's easy to see that cosine theta, which is adjacent over hypotenuse, must be 1 over radical 1 plus 4x squared. Secant of theta is the reciprocal of that. So I now know not only that tangent of theta is 2x, but I also have a formula for secant of theta in terms of x as well. Putting those values for secant theta and tangent theta into the previous formula, I find that r, the integral that I was wanting to calculate, the integral of square root 1 plus 4x squared dx, is this quantity. In this integral, the integral of x squared over radical 1 plus x squared dx, a comment that's worth mentioning is, if the top were just x instead of x squared, I could just do a substitution to do that integral. Another thought is, I could think of the thing that I'm integrating as being x multiplied by x over square root of 1 plus x squared, and then carry out integration by parts. That would work, but it's probably more trouble than it's worth. I have a square root of a positive number plus the square of something, which is related to x in a simple way, being equal to x and all. The substitution that I'm going to make will be x equal tangent of theta. If x is tangent of theta, then square root of 1 plus x squared is secant of theta, as we've mentioned before. Also, the derivative of x with respect to theta is secant squared theta, so dx is secant squared theta d theta. We now have all of the pieces that we need to convert this integral into trig functions. The result doesn't exactly fit into any of our categories, but if we're a little bit sneaky about it, we can do something. 1 plus tangent squared is secant squared, so tangent squared is secant squared minus 1. That means that I am integrating secant cubed theta minus secant theta. I can split the integral up into two pieces. This one is on the list of things that we know about, and that one is the ugly integral that we just calculated in the first example. Leaving the details of the algebra aside, I'm going to look at another example. I'd like to look at the integral of x squared over 4 plus x squared dx. There are a number of ways I can think about doing this, one of which is to notice that the bottom of the fraction is very similar to the kind of substitution we were just doing, except that there's no square root symbol. Let's see what happens if we do the substitution that seems intuitive. Letting x equal 2 tangent of theta, the quantity on the bottom, the 4 plus x squared, is 4 plus the square of 2 tangent theta, 4 tangent squared of theta, 4 times secant squared of theta. That's the bottom of the fraction. If x is 2 times tangent theta, x squared is 4 times tangent squared of theta. That's the numerator in the fraction. And the derivative of x with respect to theta is 2 times secant squared theta. dx is 2 secant squared theta d theta. These are all the bits that I'm going to need for my integral. Making the substitutions, that 4 will cancel that one out. I'll still have a factor of 2 around. Secant squared theta cancels out, so all that I'm integrating is 2 times tangent squared theta. but referring to my big list of recipes, when there's no secants and the power on the tangent is even and positive, I'm supposed to convert a tangent squared factor into secants and see what I can do with that. I know an antiderivative for secant squared, and I know how to integrate a constant, so what remains is not going to cause me any trouble. All that remains is to express this answer in terms of x instead of theta. The relationship between x and theta is that x is 2 times tangent theta. Therefore, tangent theta must be x divided by 2. So this quantity is x divided by 2. We'll get the other one in a very simple way. Putting in the indicated result, the integral is x minus 2 times the arctan of x over 2 plus a constant. And lastly, for this second short video, I'd like to look at the integral of x squared over radical x squared plus 2x plus 5 with respect to x. If it's not immediately obvious, think back to what we did in the preceding video, and the thought was that we would complete the square. So let's give that a try. It turns out that x squared plus 2x plus 5 is 4 more than the square of x plus 1. The quantity under the radical is 4 plus the square of x plus 1, 2 squared plus something squared. The u in this case is going to be x plus 1. The a is going to be 2. I'm going to have to figure out what to do about that x squared and also what to do about the dx. Expressing everything in the integral in terms of u, I must integrate the square of u minus 1 over radical 4 plus u squared du. This is now in the standard kind of trig substitution format that we've been thinking about. Obviously, I'm going to let the u equal to 2 times tangent of theta and express everything else in this integral in terms of theta. Making the usual substitutions and simplifying, I have to integrate the quantity 4 tangent squared theta minus 4 tan theta plus 1 times secant theta d theta. Splitting this up into 3 integrals, we know how to do that integral. That's on our list. We know how to do that one too. So if we can come to grips with this one, we'll be in business. I can combine these two terms. We know how to integrate secant theta. We know how to do that integral. And this one is 4 times the integral of secant cubed theta, which, although kind of horrific, we have seen several times by now. Since this has already gone on quite a while, I'll omit the details of the algebra. The result is 2 multiplied by tangent theta secant theta minus natural log absolute value secant theta plus tangent theta minus 4 secant theta plus the constant of integration. To finish this, I need to express the tangent and secant in terms of x, and then we'll be done. U is 2 times tangent theta, but u is also x plus 1. That means that tangent of theta must be x plus 1 over 2, a representative triangle would be this triangle. The length of the hypotenuse is the square root of 2 squared plus the square of x plus 1. This is also the square root of x squared plus 2x plus 5. I can now calculate any other trig function I care to. In my answer, only tangents and secants appeared. I already know tangent theta in terms of x. Cosine theta is adjacent divided by hypotenuse. Secant theta is the reciprocal of that. And if you wanted to be literal about this, in this result, every place you see a factor of tangent theta, write x plus 1 over 2 down instead. That will happen there. You'll have a term of x plus 1 over 2 here. Also, every place where you see secant of theta, write it this down instead. You'll write it there, and there, and there. The interested can complete the tedious algebra themselves, but in any case, this expresses the answer back in terms of x. Hopefully, everybody can see that the kind of manipulations we're doing here are the same general kind as when we did u equal a sine theta, but because we're using different trig functions, and therefore different trig identities, the exact details of the calculation are somewhat different. Coming up soon, the third video about these trig substitution problems. In the meantime, I hope everybody has a good day. I'll talk to you again soon.